Hello, everyone. Today we are doing exam 4, page 4 and 5, question A, B, and C. So this is going to be like finding the area under a curve using this function as given from f of x and throughout the intervals from -6 to 4. And then we have some examples up here that we may use throughout the questions. So first, let's start out with finding the area using geometry. So we know that when the x is 0, so the y at the y-intercept is it's going to be 1. It's going to be 1, and it's going to be growing at a 1 over, like a 2 over 1x run. So what that means, it's going to have, when it goes across two x intervals, it's going to increase by 1y. So then we're going to 4, so that's going to be 3. So it's going like that. And then when it intercepts the negative, it's going to be 2. Because when you plug in -2 in the function, it'll just -2 over 2 plus 1 will just be 0. So let's keep moving like that. Okay. So now we have the lines, or we have the graph of our interval and our function related to our function. So now we're going to break it into two different parts because one is in the positive y and one's in the negative y. So we're going to go down to indicate that this is going to be the negative. And we're going to go down from this 4 to represent the positive. So what I like to do is try and find the x and y of these graphs because they're right-hand triangles. So we know that from 0 it reaches a maximum of -2. And we know that the top it goes from 1, 2, 3, 4. The right-hand side is going to be 1, 2, 3, 4, 5, 6 from the x. And it's going to be a maximum height of 3. Since we know that the right-hand triangles are 1/2 of a square, we could put it in this form. So we're going to do 1 over 2 to represent the half of the square, multiplied by the base times height. And we're going to be adding these two together to find the total area under the curve. So then we'll have 1 over 2 to represent this half square of the base of 6 times 3. So this is going to be -4 because the 2 cancel out, plus this is going to be 9, or 6 times 12, 18. 18 over 2 is 9. When you add these together, it'll be 5 in total. So the total area is going to be 5. Moving on to the next question. Next, we are going to find the area under the function using integration. So what this looks like is it's going to look like, this will look like the integral of 1 over 2x, and the intervals are going to be -6 and 4. So 1/2 x plus 1. And when you antiderive it, it's going to be here, let's put it together, 1 over 2x. So this is going to be adding 1, so it's going to be x squared 1 over 2 divided by 2. Okay, so now we could do it'll just be x squared divided by 4 plus x with the integral of 4, or between the intervals of 4 and 6. With this, we're going to plug it in. So we're going to have 4 squared divided by 4 plus 4 minus, because we're finding the total area of, so we're going to subtract it of -6 squared over 4 plus -6. So simplifying this is going to be 16 divided by 4, which is just 4, plus 4, which is 8. Then we're going to be subtracting it by 36 divided by 4 minus 6. 36 divided by 4 is 9. And this is going to be subtracted by 3. So this is going to be 3. When you add these two together, you're going to get 5. So this is the same answer as we had for the graph above. Now we're moving on to the next question. So our next question is going to be find the exact area under the function over the same intervals. But however, we're going to be using the definition of the integral. So as stated when we first did the first question, it gave us some suggestions, and we're gonna find it by finding the sum. This is just the function for the definite integral. So it's gonna be xi times the change in x. And then we find the change of x by plugging in, it's going to be b minus a over n. So this is going to be, you get 4 minus -6 n, which is just going to be 10 over n. Next, we're going to find the xi, and this is going to equal a plus the change in x, the change of x times I. So this is going to equal xi after we plug it in, -6, or the x of xi will equal -6 plus the change plus 10 over 9 times I. And now we find the function of xi. So we plug in what f of x was, but instead of putting x, we put the xi. So it'll be 1 over 2 parentheses 6 plus 10 over 9 over n, I plus 1. And we're going to simplify this. So this is going to be, this is -6. We can't forget the negative. So this is going to be -3 plus, we're going to distribute the 1/2 to all of the numbers in the parentheses. So that would be 5 over n I plus 1. Remember, this is a -3, so we could just add this. So it's going to be the function of xi will equal -2 plus 5 n I. And I actually forgot to add the limit as n approaches infinity. This is just the definition of the integral, and it basically says that the limit sums as n approaches infinity. So after we plug that in, we're gonna plug it in for our final graph, or for our final definition of the integral. So we're gonna do n as I equals 1. We're gonna put -2 plus 5 over n I times the change in x. And we're actually going to move the change of x to the left side. So the limit as n approaches infinity, we're going to put 10 over n with the sum of n as I approaches 1, parentheses -2, plus 5 over n I. So now we're going to distribute this sum to both of the parentheses, to the numbers in the parentheses. So as the limit as n approaches infinity, 10I will be multiplied by the sum as n approaches 1 times -2 plus the sum of n as I equals 1, 5 divided by n and I. Let me erase that. And now that we have this distribute, I still have my eraser on. So now we have this distribute, we're going to plug in n. So as the limit as n approaches infinity, 10 over n will be multiplied by -2n plus 5 over n. We're gonna put this n we're gonna put 5 over n behind the sum. So it'll just be and then on the previous questions, the hint was that when there is an I, when the I is left alone and I equals 1, this is going to equal n times n plus 1 over 2. So we're going to plug this in. So n parentheses n as multiplied by n plus 1 over 2. These two n's cancel each other out. So now that we have, let's simplify this or rewrite this. So as a limit as n approaches infinity, we have 10n times -2n, make this sign a little bigger, plus 10n times 5n plus 5, because you're distributing the 5 with the 5n plus 1 over 2. So as we simplify this, the two n's cancel out. So this is going to be limit as n approaches 0. It's going to be -20 plus, so you're going to get, for the first distribute, you're going to get 50, and the n's cancel out, divided by 2, plus plus 550 divided by 2n, because you distribute the 10 over n for both of the functions, or for both of the equations. So now that we have this as n, let me erase this, as n approaches infinity, we're going to plug that in. Oh, sorry about this. Yeah, so we're going to plug this in. So as n approaches infinity, n turns into infinity here, and that's the only n we have in our equation. So a small number over a big number ends up to be 50 over infinity. And this is going to approach 0 because infinite amount of number divided, you have a constant number divided by infinite amount of number, it's going to be 0. So our final answer is going to be negative 20 plus 25, which is going to give us 5, which matches the other answers in our equations, or in our questions. Thank you for watching and have a nice day.